main tasks this year were climbing the bar and scoring the tennis balls into the hoop. We just chose to do the low goal, and we chose to climb on the mid rung. So here's our robot. I'll explain a little bit about it. So the climber is a one-stage continuous lift with both up and down poles. This pole is located right here. It's run off a Falcon 500. The Falcon has a gear ratio of 21:1. It's chain driven up to this 1 1/4 inch pulley. We have the down cables here, the up cables here. This is a 30-inch lift, I believe, and it's at a 32.5 degree angle to match the angle of the rungs. That's about all I have to say about that. It's a little overbuilt in some spots, a little underbuilt in others, but it did climb. We were looking at adding a feature of having stationary hooks in the center so that I could do the pass off. We didn't have enough time to do that, but that would be easily implemented to this design. So yeah, that's the climber. The intake / shooter mechanism is located in the front of the robot. It's currently in the starting configuration. We do understand that this is outside of frame. We would have cut this down. We ran out of time and kind of forgot about it. So, it's piston actuated. At the beginning of the match, she goes forward to be outside bumpers. We decided not to put bumpers on this robot. Again, a time constraint type of thing. So we're outside the bumpers and we're able to take the balls. So there's 3 sets of motors. The first motor here runs these 3 sets of front wheels. They are currently driven by polycord. So we ran out of 35 chain. Evidently there's a chain shortage in North Dakota, so we had to do polycord. This is kind of the only thing that really made this not work well, was the fact that these would slip and you wouldn't be able to intake using this roller. So I'll kind of show you how I'll go in. Intake up here. So now this will be ball position 1. So if you're only holding 1 ball, now when you're intaking, you're only running this first set of motors. We have the second ball. So, come across the second ball. You run it again. And you run the back set. These 2 are tied together in the back set. That advances them to here. And this one here. Now you're ready to shoot. The last motor is this top one. It's a 775 with a 7:1 gear ratio, doing a 4-inch Andy Mark wheel. So we spin this up. Once this is up to speed, we run both intake motors and it fires both the balls. And there seems to be very little reduction between shots, so we can shoot them right back to back. Both of them make it in the low goal, no problem. Something we were looking at doing, we didn't have time to do, but we were looking at increasing the diameter and speed and compression of the system to possibly be able to shoot the high goal. That wasn't ruled out, but we weren't able to do it with our time constraints. The drivetrain is a West Coast drive. It's got 3 cymbal shifters with 6 Falcon 500s, the strongest low gear that you can buy. It's got Omni wheels on the front, a drop center wheel in the center, and these wheels are the Andy Mark smooth grip wheels. They're the blue nitrile. and we're chain driven up to all the other wheels, so all wheels are driven. So pretty basic chassis. I highly recommend it for its versatility and its strength during competition. That's about it. We got our new electronics package here on the back. So our electronics board is the back here. We got some pneumatics. We do understand this is outside frame. It could be easily zip tied inside frame. Not too worried about that. We can get a shot maybe of the new electronics, and we got a little bit of wire management that could have been done, but this is Ri3D, so we ended up having to change out the Robo Rio 2.0 due to some software that wasn't quite ready. So we went down to the 1.0, and that's pretty much the robot. We can see a shot of this piston here. This piston is oversized, but it's the only one that we had that was long enough that could get this thing outside the frame. And I can actuate it back in here to show starting configuration. Alright, I will also actuate the climber here for you guys. So we have taken some damage to this climber, but this is how she would run. This is a pretty simple lift with some pretty simple brackets. All of this was done by hand. I didn't have any CNC machines to do any of this, but we were able to still make a pretty decent lift. That's pretty much all I got. That's a robot.